Good afternoon. My name is Cassie Starnes, and today I'll be discussing Nirenburg's experiments with both Matthaei and Leder. In 1961, Nirenburg and Matthaei published this experiment. The premise of their experiment involved E. coli bacteria, which was ground up using a mortar and pestle. By grinding up the bacteria, they allowed for a free cell design, meaning that the cytoplasm was released into the test tubes. They wanted to know which amino acid would be incorporated into a protein following the addition of a particular type of synthetic RNA. For their methods, they set up 20 test tubes, each with a different amino acid. 19 of the test tubes were cold while one was hot. They then inserted a chain of RNA containing only uracil, also known as poly-U, depicted here. When they inserted the uracil, the hot test tube only produced phenylalanine. The radioactive markings proved that the RNA was coding for the newly created protein, showing that RNA was directly responsible for the creation of the protein. RNA is noted as the key for breaking the genetic code. RNA transcribes genetic information, as shown in this experiment. They were the very first to establish the connection between RNA sequence and a specific amino acid. They then found the corresponding amino acids for both adenine and cytosine. They tried with guanine, but no amino acid was produced. However, they did not know how many uracils correlated to a single lysine. They didn't know if just one uracil, 2, 3, coded for an amino acid. This is where Nirenburg and Leder come in. In 1964, Nirenburg and Leder released this experiment. Their experiment contained a mixture of RNA and ribosomes. They then ran the mixture through a filter, which allowed most of the molecules to pass through, but did not allow the tRNA that had bound to the ribosomes to pass. Depending on which RNA molecules did not pass through the filter, they then, the investigators could decide what codons were connected to which proteins. Nirenburg and Leder could then establish which codons code for which amino acids, which then gives us the chart that we still use today, depicting which codons code for which amino acids. These experiments helped us crack the genetic code and helped us then go on for more experiments, things like that.